Hello everyone, in this video we will discuss about lateral ventricle. Now it's a cavity all around bounded by ependyma and it's a cavity of telencephalon. So this is what we have discussed regarding the third ventricle and this is its territory, and here you can see this is interventricular foramen or foramen of Monro, and deep inside the probe is going in the cavity of lateral ventricle. So this is septum pellucidum and that is forming medial wall, and the ventricular cavity actually is hidden deep to this. So if we remove this, we can straight away see the cavity. So here in this section the septum pellucidum has been removed, which is a thin sheet of white and grey matter, and this is the corpus callosum. This is the fornix. So in between we will find septum pellucidum that we have removed, and deep inside you can see the cavity of lateral ventricle. See this. Now basically there are four lobes: frontal, parietal, occipital and temporal, and so as the lateral ventricle has got four parts: anterior horn, body, posterior horn and inferior horn, and that is for descriptive purpose. So we will also discuss these four parts individually. Now you can see over here the probe is going inside. So here will be the anterior horn. Now the posterior wall or posterior boundary of anterior horn is up to the interventricular foramen. See this. So up to this point will be the anterior horn. From interventricular foramen to the splenium will be the body, and beyond the splenium within the occipital lobe will be the posterior horn, which is smallest, and the main continuation of the body will be the inferior horn that will found within the temporal lobe parallel with the superior temporal sulcus, and it will extend up to a point which is situated approximately 2.5 cm behind the temporal pole. So somewhere over here will be the extent of inferior horn of lateral ventricle. Now before going into detailed description of boundaries of individual horn or individual parts of the lateral ventricle, let's just understand some basics regarding this area, this region. So as you know, this is the thalamus and this is the interthalamic adhesion. Here will be the ventricular cavity, third ventricular cavity. This is fornix and this is corpus callosum with its four part: rostrum, genu, body or trunk and splenium, and between thalamus and fornix there is a gap. I'm just inserting this probe into this gap. See this. Now this gap is all around, so below also we will get similar gap. Okay, here also I'm bringing it bit closer. So again, in relation to the basal nuclei and thalamus and the inferior horn, okay, here the probe is going inside the inferior horn. So there is a continuous C-shaped, alphabet C-shaped gap or fissure which is allowing passage of the choroid plexus to enter inside the ventricular cavity. This C-shaped fissure is called as choroid fissure. Obviously the name is given to it just because it is allowing passage of the choroid plexus to enter inside. So throughout the course of the ventricular cavity, lateral ventricular cavity, there is a choroid fissure, and the choroid plexus is contributing the main source of secretion of CSF, and the largest choroid plexus is found along the lateral ventricular cavity. On an average, the capacity of lateral ventricle is 8 to 10 ml, and clearly you can make out if I bring it bit closer. This is the choroid fissure and this is what we were discussing. This is a fringe or tuft of capillary. This is portion of choroid plexus left over here. So this you can clearly make out from this choroid fissure. The choroid plexus will enter inside the cavity. Now see over here, from the cavity itself you can see the choroid plexus. See this. This is a choroid plexus. You can see the rough elevations, small elevations, tufts of capillaries. These are nothing but the formation of choroid plexus. Okay. See this. So there is a C-shaped choroid fissure. Now so many things are oriented in alphabet C shape. Deep inside you can see this is the caudate. Over here will be the head, then body, and tail will be over here. So that is again C shaped, and that will wind around the thalamus all around. So within the concavity of the caudate you will get thalamus. In relation to the thalamus again you will get fornix, which is again C shape. So it commences with the cross of fornix over here. Then these are the body of fornix, and over here will be the column of fornix, and that will form the anterior boundary of interventricular foramen. Okay, this is interventricular foramen. So anterior boundary is formed by column of fornix and posterior boundary is formed by the thalamus. Similarly, this is corpus callosum, again it is C shape. Then we have got the cingulate gyrus, cingulate sulcus, callosal sulcus, likewise. So many structures are oriented in alphabet C shape. Now if you have got an orientation of how these structures are related with each other, so deep inside will be the thalamus, then there is caudate, head, body and tail, and that is laterally. Medially you will get fornix, then there is a C-shaped lateral ventricular cavity, then there is corpus callosum, then there is callosal sulcus, cingulate gyrus, likewise. So all these things are oriented in C-shaped manner. Now here I have got a corrosive cast, and that is of actual size of ventricular cavity. The synthetic resin like material is inserted within the ventricular cavity and then it is allowed to settle down, and after that the soft tissue is removed. So all what we get is the lumen or the cavity itself. Now this is the lateral ventricle left side. You can get an orientation, and here will be the interventricular foramen. This is the cavity of third ventricle. So this is of left side. Okay, and as we have discussed, it is having anterior horn. So beyond interventricular foramen, this will be the anterior horn. Then up to the splenium, somewhere over here will be the central part or the body, and then this is the smallest posterior horn, and the continuation of the central part is the inferior horn. So this is how again it is a C-shaped cavity, and it is in connection with the third ventricular cavity with interventricular foramen, and this gap is suggestive of the interthalamic adhesions, which will not allow this resin material to enter, and this will remain as a gap. So this is how, this is to just give you an orientation. This is how it looks like. Now if we correlate it with the section, so this is right cerebral hemisphere, and deep inside will be the right ventricular cavity, and this is the third ventricular cavity. So if we just approximate these two together, see this, and this is how the cavity will be inside. Just imagine a mirror image of this left ventricular cavity. So deep inside will be the right lateral ventricular cavity, and this is the anterior horn. So somewhere over here will be the anterior horn. You can clearly make out the anterior horn. Okay, then there is central part up to the splenium. Then this is the posterior horn. So over here will be the posterior horn within occipital lobe, as we have discussed, and its continuation is the inferior horn. So deep inside within the temporal lobe over here we will get inferior horn. So this is just to give you an orientation about how the cavity will be found within the telencephalon. See this. Okay. Similarly, this is another corrosive cast, and now you can easily make out this is third ventricular cavity. Here will be the interventricular foramen, and this is the right sided lateral ventricle, anterior horn, central part, posterior horn and inferior horn. And if we connect it with its counterpart. This is of left side, and if we try to join these two together, say this is how the entire lateral ventricle looks like. If we see both the things, both the cavities from above, in the center will be the third ventricular cavity, and just see it from in front, right and left. If we join these two together like this, anterior horn, central part, now we can make out the inferior horn clearly, and then we have got the posterior horns. Okay, now one more thing I wanted to show you is, as we have discussed, continuation of third ventricle is the cerebral aqueduct of Sylvius. So some amount of the material has also entered inside the cerebral aqueduct, and you can see the tubular structure. This is nothing but the cavity of aqueduct of Sylvius, and here will be the recesses of third ventricle. Okay, so these are all extensions, and this is the anterior horn, central part, posterior horn, and portion of inferior horn. So this is how it should be inside. Just see the comparison. Okay, so if we can insert it like this deep inside, then it will lodge the entire cavity. Now let's see the boundaries of individual parts. So first is the anterior horn. Now, as we have discussed, it is found within the frontal lobe, and it is extended up to the interventricular foramen. So this is the territory of anterior horn, and if you see it from the gap of the septum pellucidum, you can make out that this is the anterior horn. This is how it goes inside. Now it is all around bounded by this corpus callosum. So this is the body or trunk of the corpus callosum, this is genu, and this is rostrum. So obviously the anteriormost limit, okay, if I insert my probe deep inside, the anterior limit is by the posterior surface of genu. This is genu, and its inner surface, posterior part, will form the anterior limit. So anterior wall of the anterior horn is formed by posterior surface of the genu. The roof is formed by undersurface of the trunk, obviously you can make out, and so as the floor is formed by superior surface of the rostrum. So anterior wall, roof, and floor are formed by the corpus callosum itself. Lateral wall, you can clearly make out, this is the bulge you can see deep inside, and the anteriormost bulge will be the head of caudate. This is the body of caudate. So lateral wall of the anterior horn is contributed by head of the caudate, and medial wall, obviously this gap is filled by septum pellucidum. Say this. So this is interventricular foramen, so up to this point will be the anterior horn, and its medial wall is formed by septum pellucidum. So these are the boundaries of anterior horn. Next is body or central part. So it extends from interventricular foramen to the splenium of corpus callosum. So this is the territory of the central part of the body. Now the roof is formed by undersurface of the trunk or the body of corpus callosum. See inside, here will be the roof, and the floor is slopy from lateral to medial. Okay, so extremes of the floor and extreme of the roof will merge together, so there is no lateral wall. So straight away from roof you will get floor, and here will be the medial wall. So three boundaries for the central part: roof, floor, and medial wall. Now roof is contributed by undersurface of the trunk or the body of corpus callosum, whereas the medial wall is contributed by septum pellucidum. Now what is left is the floor, and as we have discussed, it is slopy from lateral to medial. So lateral most you can clearly make out the bulge. This is the bulge produced by the body of caudate nucleus. The head is contributing boundary of anterior horn, and the body is contributing boundary of the central part of the lateral ventricle. So the floor, lateralmost structure, is formed by the body of caudate nucleus. Then comes a ridge, you can see, of white matter. This is the efferent from amygdala. This is termed as stria terminalis. And next to that ridge, you can clearly make out a bluish structure. See, I am bringing it a bit closer. So this is the thalamostriate vein. Okay. Next to that will be the superior surface of thalamus, and for that we need to cut this portion of the cerebral hemisphere, and we need to see it from inside. So there is a coronal section I have. See this. So this is to show you both the sided central part of the lateral ventricle. Now you can clearly make out the roof and the floor are in relation with each other, so there is no lateral wall. So roof is formed by endosurface of the trunk, and the lateral wall, okay, here will be the body of caudate nucleus. Then there is stria terminalis and thalamostriate vein, and this is the thalamus. So its superior surface lateral part will form the floor. Next will be the choroid plexus within the choroid fissure. See, this is the choroid plexus, and medialmost boundary will be the superior surface of fornix. See, this is the fornix. Okay, this is septum pellucidum. So here will be the fornix, and that contributes the medialmost part of, and as we have discussed, the medial wall is contributed by septum pellucidum, which is lined by ependyma on either side. So this is how the central part is bounded. Now the same thing we can discuss in a diagram. Now here in this diagram you can see the same things what we have discussed. This is corpus callosum, its body. This is septum pellucidum. This is the fornix, and this will be the superior surface of body of the fornix. Here will be the choroid fissure, as we have discussed, between thalamus and fornix will be the choroid fissure containing choroid plexus, and here will be the body of caudate. This is under surface of the trunk of corpus callosum. So all around are the boundaries of central part of the lateral ventricle. Roof you know now, medial wall you know, and what is important to understand is the floor from lateral to medial. As we have discussed, it is slopy. So most lateral structure will be the body of caudate. Then there is stria terminalis, thalamostriate vein, again both the things we have seen. Then this is the thalamus, this is its superior surface, and this is its lateral part. So lateral part of superior surface of thalamus contributes to form part of the floor of central part, and between thalamus and fornix will be the choroid fissure containing choroid plexus, and then comes the upper surface of body of fornix. So these many structures are forming floor. Only structure forming roof is the undersurface of the trunk, and only structure forming medial wall is the septum pellucidum. So these are the boundaries of central part. Now again in this coronal section, this was the posterior half. Okay, this is the occipital pole. So this is the posterior half. Now if you want to see the anterior part, and if you want to see the anterior half from behind, how the central part of the lateral ventricle looks like, so again we need to cut another cerebral hemisphere, and this is what we have. So this is what we were discussing, and I have already shown thalamostriate vein and stria terminalis, plus this is the choroid fissure will be containing choroid plexus. Now if we take a coronal section right through this thalamus, right through the central part of the lateral ventricle, and if we see from behind, let's see how it looks like, and let's just compare it with the diagram. So let me take a section from the central part. So now I have taken a section, and what so far we have seen was the posterior half of the central part, but let's just see the anterior half from behind. Okay, so now you can easily get an orientation where exactly will be the choroid fissure. Okay, this is the fornix, and deep inside will be the choroid fissure containing choroid plexus, and this will be the thalamus. See this. Okay, so this will be the thalamus, choroid fissure, fornix. This is the cavity. Deep inside will be the body of caudate. This is under surface of the corpus callosum, and the septum pellucidum we have removed. So the same thing if you imagine from behind, okay, and the same thing you need to now correlate with the diagram. That is what we have discussed. This is the trunk of the corpus callosum. From lateral to medial we will get body of caudate. Say this is the head and this is the body of caudate. You can clearly make out the bulge inside the cavity. So this is the gray matter, you can clearly make out body of caudate. Then there is a strip of white matter. Let me bring it a bit closer. You can clearly make out the stria terminalis. Say this is the white matter, bundle of white matter extending from amygdala, and it will reach up to the anterior commissure and will go to the septal area. So this is the stria terminalis, and medial to that you can clearly make out a bluish colored structure. This is thalamostriate vein, and you can appreciate its lumen. So just next to this vein will be the stria terminalis, and this is thalamostriate vein itself. Now you can clearly make out both the structures, stria terminalis and thalamostriate vein. See, I have separated it. And then comes the thalamus. See, this is the thalamus, and this is its superior surface. This is its lateral part. That is what we have seen in diagram. So 4 structures from lateral to medial: body of caudate, stria terminalis, thalamostriate vein, lateral part of superior surface of the thalamus, and then comes the choroid fissure, okay, the gap between fornix and the thalamus containing choroid plexus. You can see part of the choroid plexus preserved, and then comes the fornix itself. See over here, portion of choroid plexus is seen, and just medial to that will be the superior surface of body of fornix. So these are the boundaries or the structures forming floor of the central part, and in the midline over here will be the septum pellucidum, filling the gap over here. So this is how central part is oriented. Now next will be the posterior horn, and just before understanding the boundaries of posterior horn, I want to tell you 2 important things. This is the splenium of the corpus callosum, and the posteriormost fibers, commissural fibers passing through the splenium will be the forceps major, and that will produce an indentation into the medial wall of the posterior horn, that will be termed as bulb of the posterior horn. And similarly this is calcarine sulcus just below the splenium, and anterior part of the calcarine sulcus will also produce an indentation within the medial wall of the posterior horn, that is termed as calcar avis. So 2 indentations will be found into the medial wall of the posterior horn. Now remaining boundaries are contributed by the fibers passing through the corpus callosum, which are not intercepted by corona radiata, and that is termed as tapetum. So the roof, lateral wall and floor are C-shaped boundaries contributed by fibers of tapetum, whereas the medial wall is contributed by bulb of posterior horn and calcar avis. Now the posterior horn, inferior horn and the central part of the lateral ventricle will basically trifurcate, okay, and that forms a triangle over here, and that is termed as collateral trigon. So let me just show you it in a section. So beyond the splenium, the central part will continue as inferior horn and posterior horn, and that area of division will termed as collateral trigon. Now this is the anterior part of calcarine sulcus. This is its posterior part. This is what we have seen in diagram, and this is splenium. So deep inside will be the posterior horn, and from medial side, see this, you can clearly make out from the medial aspect both this bulb, both this forceps major and calcarine sulcus will produce indentation, and respectively they will form bulb of posterior horn and calcar avis. Now the same thing we can appreciate in a diagram, and then again we will cut this portion and we will try to see the boundaries. So this is splenium and this is the calcarine sulcus, its anterior part, and if you imagine the posterior horn next to it deep inside, and if you try to figure it out, a section passing through the posterior horn, then this is how it looks like. So this is the cavity of posterior horn, and this is the forceps major which is coming from the splenium, and deep to it will be the anterior part of the calcarine sulcus. Now these two will produce indentation in the medial wall. So this is termed as bulb, which is produced by forceps major, and this is termed as calcar avis, which is produced by anterior part of calcarine sulcus. And as we have discussed, the tapetum will form roof, lateral wall and below floor. So remaining three boundaries are formed by tapetum only, whereas only medial wall is contributed by bulb of posterior horn and calcar avis. Now the fibers forming tapetum will separate ventricular cavity from optic radiation. So this is how a coronal section from the posterior horn will look like, and let's just try to take a section from this region and let's just compare it with the diagram. So now I have taken sections. This was the original section, and then I have taken two sections, basically one through the splenium and one just behind the splenium. So let's just see it one by one. This will be the anterior part. Now this will be the termination of the central part at the splenium, so that we can see from behind. This is how it looks like. Okay, you can see choroid plexus inside the cavity. See, this is how it looks like. And now when we see the posterior horn from in front, see, this is how it looks like. So this is the splenium, and this will be the tapetum. See, you can appreciate a shiny structure. Okay, deep inside will be the ependyma. So next to the ependyma, this white strip, because the fibers are running parallel to the coronal section, so it will become shinier, it will look whitish as compared to a dark structure. You can see the strip. This is optic radiation, because the optic radiation will be going towards the occipital pole, so it will be perpendicular to the coronal section, so it is darker as compared to the thin white strip. This is tapetum, and now we can clearly make out the roof, lateral wall and floor. All around it is formed by tapetum, whereas inside the cavity within the medial wall you can appreciate two elevations. See, this is one and this one is another. So this is the bulb, which is produced by forceps major, and this is calcar avis, which is produced by the calcarine sulcus anterior part. Now again you can appreciate this is posterior part and this is anterior part of the calcarine sulcus, and deep inside this anterior part will produce an indentation, and this is an example of complete sulcus. So here is the indentation. So medial wall is formed by two elevations, whereas roof, lateral wall and floor is formed by tapetum. Again, when you see another section just behind the splenium, and when you try to see it from behind, okay, and when you try to correlate it with the diagram what we have seen, the first bulge will be of the bulb and second bulge will be of the calcar avis, and this is all around the roof, lateral wall and floor by tapetum. Next to it is the darker structure, that is optic radiation. So this is how from behind the posterior horn looks like, and the most extreme part of the posterior horn, say this is how it terminates. Again you can appreciate two bulges along the medial wall, and you can appreciate the tapetum, and when you join these two together you can clearly appreciate entire posterior horn deep inside. Say this, and when I remove the posterior section you can appreciate cavity of the posterior horn alone. Say this, and the same thing you can correlate with the corrosive cast we have. So when you take a section beyond this collateral trigone, we are over here actually, and we are seeing it from in front. So this is how it looks like. This is how the section looks like. Okay. Now next is inferior horn, that is found within the temporal lobe, and that is found above this collateral sulcus. Extreme of the inferior horn is found 2.5 cm behind the temporal pole. So somewhere over here deep inside the temporal lobe we will get the inferior horn. And again, like calcarine sulcus, this collateral sulcus will also produce an indentation within the floor of inferior horn, and then it is termed as collateral eminence. This is another example of complete sulcus. So far we have discussed two complete sulci: anterior part of calcarine sulcus and collateral sulcus. This is producing calcar avis and this is producing collateral eminence. Now again, this is the same coronal section just now we have seen, and this is the slit like cavity of inferior horn. Now try to correlate it with the diagram, and this is the hippocampal formation. See this ram's horn, and next to it will be the collateral eminence, okay, by collateral sulcus. So this will be the floor and the elevation. This is the fimbria formed from alveus, and beyond fimbria will be the commencement of crus of fornix. Now this is the roof. Laterally it is contributed by tapetum. You can see white shiny structure, and over here will be the tail of caudate, okay, and commencement of stria terminalis. Between stria terminalis and this fimbria will be the choroid fissure, and you can clearly make out the choroid plexus. Say this is choroid plexus. So here will be the choroid fissure. Now let's just try to see the same thing in a horizontal section passing through the cavity, and we will try to see the formation of alveus and formation of fimbria from above. So if we take a section through the cavity, we can easily see the floor. So here will be the temporal lobe, and deep inside will be the inferior horn. And to see the inferior horn from above and side, I have just sliced out the portion of temporal lobe. See this entire portion of temporal lobe has been removed, and you can see from posterior superiorly. See, here will be the cavity of inferior horn, as it is a slit like. So this will be the cavity, and this is the hippocampal formation. See how it looks like. So the same thing we have appreciated in a coronal section. This is what in horizontal section I have tried to preserve the hippocampal formation, and behind to that you can appreciate the choroid plexus. See this, okay. Deep inside will be the cavity of posterior horn, and straight away this is the region of collateral trigone, and beyond that we will reach to the central part. So this is the inferior horn. Here will be the roof, and this white shiny structure over this hippocampal formation is the alveus, and this alveus will condense along the medial side to form fimbria, and beyond the fimbria is continuous as crus of fornix. So let me just try to show you formation of fimbria, and for that we need to remove this choroid plexus, and we need to see the entire hippocampal formation from above and medially, and that will expose the fimbria. So in section I have shown you how the fimbria looks like. Now over here you will get the fimbria. So let me just cut this portion of choroid plexus, and let me just clear this area to show you the fimbria. So I have removed portion of temporal lobe, parietal lobe and occipital lobe, and just focus on this structure. This is hippocampal formation forming the floor, and its medial most part now you can clearly appreciate. This is the white sheet forming alveus, and over here you can see a ridge. See this is the ridge, this is fimbriae, and this fimbriae is continuous as cross of the fornix. This is cross of the fornix. Let me show you the same from medial aspect. See this. Now you can clearly make out this is the crus and the same crus over here, and then it forms the body of fornix, and beyond that this is the column of fornix. So this is how the entire fornix you can appreciate. See this, the same fornix what we have seen from the central part. So this superior surface of the fornix will form floor, medialmost part of the floor of the central part, and same this fornix is continuation of this fimbriae, and beyond that this is alveus, and this is entirely the hippocampal formation. And this gap between the thalamus and the fornix, this is the choroid fissure which is C-shaped. Throughout you can now appreciate the entire choroid fissure. See this, and that is lodging choroid plexus. See over here again from in front also, this is the choroid fissure between thalamus and fornix. So the same thing over here also, choroid fissure. So this is regarding boundaries of lateral ventricle. Hope you understood well. Thanks for watching.